Welcome to this comprehensive guide on machine learning. In this video, we're going to delve deep into the fascinating world of machine learning, exploring what it is, its various types, some basic algorithms, and real-world examples of how machine learning is revolutionizing industries today. Imagine a world where your computer not only follows your instructions but also learns from its experiences, just like humans do. Sounds intriguing, right? Well, that's precisely what machine learning is all about. Let's embark on this exciting journey together. What is machine learning? Machine learning is a subset of artificial intelligence, AI, that involves the development of algorithms allowing computers to learn from and make decisions based on data. Unlike traditional programming, where a computer is explicitly programmed to perform a task, machine learning enables the system to learn from experience and improve its performance over time without being explicitly coded for each specific task. Think of it like teaching a child to recognize animals. Initially, you show the child pictures of different animals and tell them which one is a dog, a cat, or a bird. Over time, the child learns to identify the animals on their own. Similarly, in machine learning, we feed data into a computer, and it learns patterns, correlations, and structures from that data. Once the learning phase is complete, the machine can make predictions or decisions based on new data. This ability to learn and adapt is what makes machine learning such a powerful tool. Machine learning is used in a variety of applications today, from recommendation systems and image recognition to autonomous vehicles and natural language processing. It has the potential to transform industries by automating complex tasks and providing insights that were previously unattainable. Types of machine learning. Machine learning can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Each type of machine learning has its own set of algorithms and techniques, and they are used for different types of tasks. Supervised learning. Supervised learning is the most common type of machine learning. In supervised learning, the algorithm is trained on a labeled dataset, meaning that each training example is paired with an output label. The goal is for the algorithm to learn a mapping from inputs to outputs that can be applied to new, unseen data. There are two main types of supervised learning tasks: classification and regression. Classification. In classification, the goal is to assign a label to an input based on its features. For example, an email spam filter classifies emails as either spam or not spam. Regression. In regression, the goal is to predict a continuous output value based on input features. For example, predicting house prices based on features like square footage, number of bedrooms, and location. Supervised learning algorithms include linear regression, logistic regression, decision trees, support vector machines, and neural networks. Unsupervised learning. Unsupervised learning deals with unlabeled data, meaning that the algorithm tries to learn the underlying structure of the data without any explicit instructions. The goal is to find patterns, correlations, or clusters in the data. There are two main types of unsupervised learning tasks: clustering and association. Clustering. Clustering involves grouping data points that are similar to each other. For example, a marketing team might use clustering to segment customers into different groups based on their purchasing behavior. Association. Association involves finding rules that describe large portions of the data. For example, a supermarket might use association to find that customers who buy bread also tend to buy milk. Unsupervised learning algorithms include k-means clustering, hierarchical clustering, and a priori algorithm for association rule learning. Reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with an environment. The agent receives rewards or penalties based on its actions and learns to maximize the cumulative reward over time. Reinforcement learning is often used in scenarios where the optimal solution is not known in advance and the agent must learn through trial and error. Applications include game playing, robotics, and autonomous driving. Key components of reinforcement learning include the agent, the environment, actions, rewards, and the policy. The agent learns a policy, which is a strategy for choosing actions based on the current state of the environment to maximize the expected reward. Basic algorithms in machine learning. Now that we have an understanding of the types of machine learning, let's dive into some basic algorithms that are commonly used in machine learning. These algorithms are the building blocks of many machine learning models. Linear regression. Linear regression is a simple yet powerful algorithm used for regression tasks. The goal of linear regression is to model the relationship between a dependent variable, target, and one or more independent variables, features, by fitting a linear equation to the observed data. The equation of a simple linear regression model is y equals mx plus by equals mix plus by equals mx plus b, where y is the dependent variable, xxx is the independent variable, m is the slope of the line, and bbb is the y-intercept. The algorithm works by finding the best fitting line through the data points that minimizes the sum of the squared differences between the observed values and the values predicted by the model. Linear regression is widely used in various fields, including economics, finance, and social sciences, for tasks such as predicting sales, forecasting stock prices, and analyzing trends. Classification algorithms. Classification is a fundamental task in machine learning, and there are several algorithms used for classification, including logistic regression, decision trees, and support vector machines. Logistic regression. Despite its name, logistic regression is used for classification tasks. It models the probability of a binary outcome, e.g., yes, no, spam, not spam, using the logistic function. The output of logistic regression is a probability value between 0 and 1, which can be thresholded to make a binary decision. Decision trees. Decision trees are tree-like models used for both classification and regression tasks. They work by recursively splitting the data into subsets based on the value of an input feature. Each internal node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. Decision trees are easy to interpret and visualize. Support vector machines, SVM. SVM is a powerful classification algorithm that works by finding the hyperplane that best separates the data into different classes. The hyperplane is chosen to maximize the margin, which is the distance between the hyperplane and the nearest data points from each class. Clustering algorithms. Clustering is an important task in unsupervised learning, and K-means clustering is one of the most popular clustering algorithms. K-means clustering. K-means clustering partitions the data into K clusters, where each data point belongs to the cluster with the nearest mean. The algorithm starts by randomly initializing K cluster centroids and then iteratively updates the centroids and assigns data points to the nearest centroid until convergence. K-means is widely used in market segmentation, image compression, and anomaly detection. Hierarchical clustering. Hierarchical clustering builds a hierarchy of clusters by either repeatedly merging smaller clusters into larger ones, agglomerative clustering, or splitting larger clusters into smaller ones, divisive clustering. The result is a dendrogram, which is a tree-like structure that represents the nested grouping of data points. Real-world examples of machine learning. Machine learning is not just a theoretical concept, it has practical applications in various domains. Here are some real-world examples of how machine learning is being used today. Healthcare. Machine learning is transforming healthcare by enabling more accurate diagnostics, personalized treatment plans, and efficient healthcare management. Medical imaging. Machine learning algorithms can analyze medical images, such as X-rays, MRIs, and CT scans, to detect abnormalities and assist radiologists in diagnosing diseases. For example, deep learning models have been developed to identify tumors, fractures, and other conditions with high accuracy. Predictive analytics. Machine learning can predict patient outcomes based on historical data. For instance, algorithms can analyze electronic health records to predict the likelihood of readmission, disease progression, and treatment response, allowing healthcare providers to intervene early and improve patient care. Drug discovery. Machine learning accelerates the drug discovery process by analyzing large datasets of chemical compounds and predicting their effectiveness and safety. This can significantly reduce the time and cost of developing new medications. Finance. In the finance industry, machine learning is used for fraud detection, risk assessment, and algorithmic trading. Fraud detection. Machine learning algorithms can analyze transaction data to identify patterns indicative of fraudulent activity. By continuously learning from new data, these algorithms can adapt to emerging fraud tactics and protect financial institutions and customers. Risk assessment. Machine learning models can assess the creditworthiness of loan applicants by analyzing their financial history, spending behavior, and other relevant data. This enables lenders to make more informed decisions and reduce the risk of default. Algorithmic trading. Machine learning algorithms can analyze market data and execute trades based on predefined strategies. These algorithms can process vast amounts of data in real time, identify trading opportunities, and optimize trading performance. Retail. Machine learning is revolutionizing the retail industry by enhancing customer experiences, optimizing supply chains, and personalizing marketing efforts. Recommendation systems. E-commerce platforms like Amazon and Netflix use machine learning to recommend products and content based on user preferences and behavior. These recommendation systems analyze purchase history, browsing patterns, and user feedback to provide personalized suggestions. Demand forecasting. Machine learning models can predict future demand for products based on historical sales data, seasonal trends, and external factors. This helps retailers optimize inventory levels, reduce stockouts, and improve supply chain efficiency. Customer segmentation. Machine learning algorithms can segment customers into different groups based on their behavior, demographics, and preferences. This enables retailers to tailor marketing campaigns, promotions, and offers to specific customer segments, increasing engagement and sales. Autonomous vehicles. Autonomous vehicles, or self-driving cars, rely heavily on machine learning to navigate and make decisions in real time. Perception. Machine learning algorithms process data from sensors, such as cameras, lidar, and radar, to perceive the environment. These algorithms can detect objects, pedestrians, other vehicles, and traffic signs, and understand the vehicle's surroundings. Navigation. Machine learning algorithms help autonomous vehicles navigate by analyzing map data, traffic information, and real-time sensor inputs. These algorithms plan the vehicle's path, optimize routes, and adapt to changing conditions. Decision-making. Machine learning enables autonomous vehicles to make decisions based on their perception and navigation inputs. For example, the vehicle must decide when to change lanes, merge into traffic, or stop at a pedestrian crossing. Reinforcement learning is often used to train these decision-making algorithms. Conclusion. In conclusion, machine learning is a powerful and transformative technology with a wide range of applications across various industries. From healthcare and finance to retail and autonomous vehicles, machine learning is enabling new capabilities and driving innovation. Understanding the basics of machine learning, including its different types and key algorithms, is essential for anyone interested in this field. As machine learning continues to evolve, it will undoubtedly play an even more significant role in shaping the future of technology and society. We hope you found this comprehensive guide on machine learning informative and engaging. If you enjoyed this content, be sure to subscribe to our channel for more insights into emerging technologies and trends. Thank you for watching.